So now I'm going to speak about the European Foulbrood and its detection and our experience we have from the Czech Republic. So the European Foulbrood, probably it's known disease by the beekeepers, is the bacterial disease which is caused by the bacterium Meliscoccus plutonius, which is spread all over the world where the bees are present, of course. This bacteria is non-sporulating and it's very dangerous for the honeybee larva, because if the healthy larva is the bacteria, then the bacteria emerge and make more bacteria in the intestine, and then the larvae dies. And then the dead larvae is a source of bacteria for the other larvae, and then the disease is spread inside the colony and inside the apiary. The other thing regarding the European Foulbrood is that there are several strains of the Meliscoccus plutonius. Some of the strains are, let's say, nice. They are not very much sporulating, and the disease is not that damaging for the colonies. But we also know some other strains which are very dangerous for the colonies. So what happened here in the Czech Republic in the past time when we were Czechoslovakia? So we had outbreaks of the European Foulbrood since 50s till early 80s. And then we had a gap. Nobody knows why the disease disappeared somehow. And then in 2015, we had 5 new outbreaks of this disease. And since then, we have the issue again. The last years, like here, 23, 4, and 5 are missing because official data are not available right now. But we know that in this year, it's more than 20 or maybe even more than 30 outbreaks of this disease in our country. So here's again the historical picture. Like in the past, we have the outbreaks, the hotspots were here in the South Bohemia. It's close to Austria and Bavaria in Germany. But now the situation is completely different. The outbreaks are here in the north of the country and also here in the east. I think it's obvious that now the outbreaks are close to the Poland border, and of course beekeepers are discussing if it's possible that the disease could come from Poland or from other sources. When I read the old literature regarding the European Foulbrood in Czechoslovakia, the scientists at that time discussed that the hotspots of the Central Bohemia or South Bohemia here, that it's because typical climate, which is here, because here are lakes, a lot of water, so maybe the high humidity and typical microclimate conditions could have an impact of the spread. But now we see something completely different here because the north of the country, it's mostly mountains. So I think more than 5 or 7 years ago, we got a few questions. So how much is the European Foulbrood spread in the Czech Republic? And if there is some method we can use, like a simple method, non-invasive method, we can use for European Foulbrood screening. And the candidate for the sample, for the matrix was Hive debris. And then it's a practical question, is if the early detection of European Foulbrood could be beneficial for the beekeeping practice. If the beekeeper finds the diseased colony early, it could help the whole apiary. So what we did, we used this paper sheets, which is like a common sheet, like from notebook size, for example, and it's covered by sieve. Then these sheets are inserted into the bottom board of the colony and left there for approximately 2 weeks. And after 2 weeks, this sheet is covered by the hive debris, which is wax usually, and maybe that bees, that larvae, but the majority is a wax. And then this paper sheet is transported to the laboratory for the other analysis. And even PCR machine could be very expensive. Then once you have it, then the method, it's not that expensive. So we use qPCR and PCR for this European Foulbrood detection, or better to say, the Meliscoccus plutonius detection. So we sampled the hive, the hive debris from the hives. Then we extracted DNA from the hive debris, and then we used this DNA as a template for PCR. At the beginning, we used conventional PCR, which ends up with the gel, and you clearly see if there is a signal like this, it means that the bacterium is there. If you see nothing, like here in this part of the picture, it's probably a healthy colony. But then you can detect infected or even single colonies or whole apiaries. And then the next part is again the beekeeping part. So if the results is negative, I think it's already good news for the beekeeper because colonies are healthy. But if the PCR gives a positive result, it means that the bacterium is present, but not necessarily with the clinical symptoms. So now is the time for the beekeeper to start with the disinfection, sanitation of the apiary, or the beekeeper should change the beekeeping system and the management of the colonies to minimize the spread of the disease. And of course, this should be followed by the national legislation. I don't know the registration in Ukraine, but here in the Czech Republic, if you find the clinical symptoms of the European Foulbrood, you have to ban the whole apiary. It doesn't matter if it has 1 colony or 100 colonies. So this is our current methodology. So if I go back to our answers, we found 2 hotspots in our country in 2024. The one hotspot is here in the north. Here we found, let's say, 2% of infestation of the colony, but the really hotspot is here in the east, where the 1/4 of colonies are with the clinical symptoms and are diseased. And this year we sampled whole country or random spots of the country, and now we know that only is the north part of the country is really suffering from the European Foulbrood. And we wrote a scientific publication, which I show you later, but we validated and developed the method for PCR examination of the presence of the Mesococcus plutonius. It works pretty well, and it has good practical value because it's simple, and it's simple at the beekeeping level, at the beekeeper level. It's also very simple at the laboratory level. You only need the QPC or the PCR machine. And this early detection could really help the beekeeper to save the colonies before they die for European Foulbrood. We measured some analytical parameters, which is sensitivity and specificity. These numbers are relatively high because the range is from 0 to 1, and the numbers are very close to 1. And I think I should also comment this false positives and negatives cases. The false positives means that we detected the Mesococcus plutonius, and then the inspection did not show the clinical symptoms, I mean the dead larvae. It means that the beekeeper did the sanitation, disinfection of the material, and later the disease disappeared or the concentration of the bacteria was very low. Other case is this one, when the PCR was negative, but then later inspection detected the clinical symptoms. And these beekeepers or apiaries, they were at the bad time, at the bad location, because the invasion of the bacteria from other apiaries from the neighborhood, by robbing, by moving colonies, by swarms, and maybe some other transports. So I think the method could be very valuable right now. So to summary, it's not like the hard science like CF presented in the previous presentation, but this is something how science could help the practical beekeeping to avoid spreading of the diseases. Here is based of the sampling of hive debris, then the PCR screening, and then the next step, which is on the beekeeper's side, and the beekeeper should do something what is good and legal in his region to save the colonies. And yeah, of course, the method was published here in this publication a few years ago. So thank you very much for your attention.
Thank you very much, Jiří. We have more our speakers joining us, and now we have greetings from Chile. Patricia joined us, and there is a question from Patricia. I would like to ask Jiří, is the bacteria was present in the bottom board paper, and how sensitive was the use of this method?
Hi, Patricia. Yeah, the bacteria. If the bacterium is present in the colony, then it's probably present on the wax, and it falls down to the paper sheets, and then you extract the DNA from the paper and from the box. And I'm not sure if I remember the correct numbers, but if it's about 1,000 bacteria per gram of the hive debris, you are able to detect by the PCR. But I would need to check the publication. I'm not pretty sure right now with this number. It's really highly sensitive.